All right, well, I guess here we go. Back up with another stream. Looks like we're going to be doing some more AC analysis. More of the sinusoidal steady state, things of this nature. So let's go ahead and jump right into it. Let's do so with a fresh sheet of paper. So for the circuit shown, I believe we did that. We did that. I don't believe I've done this. Did I do the one before? Previously. I don't remember this one either. Alright, we'll start here. 150. Okay. This is our circuit. We got an independent voltage source running out to this resistor here in series with this capacitor. This capacitor is in parallel with this resistor and this inductor. Alright, we need to draw our ground as our reference. That's our 0 volts, right? VG. Alright, let's label, give some names and some values. 150 ohms, 4 millifarad, 10 ohms, and 2 Henry. So like that, millifarad. Okay. And this is I naught. Now, the frequency of the sinusoidal voltage source in the circuit is adjusted until the current I naught is in phase with VG. Right, until I naught is in phase with VG, or I out, I naught, I'll call it I out. Alright, I out is in phase with VG. Okay. So to my understanding, this would mean that the imaginary part of what is it, the impedance, would equal 0, the impedance. I don't know, let's give it a shot. Okay, the impedance. So, of what point? No, I don't think we're to the point of distinguishing between a device and a source, essentially, is how we could describe it. So, okay. Well, Z total would equal 150 plus. Alright, I have enough room here. We'll write the phasor term. Okay, we'll put it in phasor form. So 4 millifarad would equal J omega L, or J negative J divided by omega C. Omega C. No. I don't have my calculator. That's disappointing. Okay. Let me pull up the calculator on my phone. And I obviously need to charge my battery. Yes. So, it's true. We'll get there in a moment. Z total, 150 in series with what? Okay, that's right. So we'll put it in brackets. Negative J divided by 4 millifarad multiplied by omega. So that would be 1 divided by 4 e negative 3. 250 over omega. We could do over positive. Over J omega. And then, shit. I'll write it all out. Okay, so literally 1, because we got to put it in parallel, and so I'm going to write this out what it algebraically would mean. which I guess, no, we'll just make it positive and write it like this. So 1 over j omega c. Right, and this positive. Plus 1 divided by 10 plus 2 Henry. No, that's not true. J omega L. Let's see. Yeah, that's right. Okay, we'll write in just its variables. L. Yeah, like that. J omega L. Does that look funny? Okay. J omega L. 1 divided by that also. That's the term itself. That's over that. That's over the fraction. Okay. 50 plus 1 divided by 1 j omega c plus 1 over 10, 0.1. Let's just add it up like this. 0.1 plus 1 over j omega L. It just is what it is. 1 over j omega L. 110. But that's not. No. See, that's the mistake. That's a mistake. These two are in series, so it would come preceding the Brillo network, and it'd be plus j omega 2. Alright, j omega L at that point. So 1 divided by. Okay, and then all this under the 1 still a reciprocal. So if we're to write this out, so this would be j omega c, which is 4 millifarad, plus 1 divided by and then I'd have to switch it to phasor form for that shit. Okay. Wait, plus 1, yeah. Okay. Yeah. Oh yeah, and then all this still under 1. Well, now that we have it all under 1 fraction, we could just flip it. Yeah, that's all it would be. So, well, would we want to do that though? Or can we simplify it? Yeah. Wait, we actually can. So, but then that still have to be under this term. Let's I think we just have to maintain that. So imagine we did this. Well, not imagine, just consider this. Consider what I'm about to do, is what I'm saying. So, right, all of that, I'll write it all out. Well, nah, I'll write it like this. I have to convert it. right? We're essentially multiplying by 1. Okay, we can introduce this term. And then we gotta maintain all divided 1 divided by all this. So therefore, that would look like this. Man, it's a lot of term. No, not necessarily. Let's just do that. So we'll say multiplied by, so we'll do a distribution here, and then we'll multiply this in later. 10 times 10, 100. 10 times negative j omega 2 minus j omega 20. J omega 2 positive, right, plus j omega 20. And then j omega 20, or 2, multiplied by negative j omega 2 is a negative j squared omega squared 4. Right, yeah. Okay, and we know what j is, right? J is the imaginary number, so you could denote it as I, or j, but equals j equals the square root of negative 1. Right, so you have a squared, that's just negative 1. So this would simplify to, and now, right, wait, did I just introduce that here? No, that's what I wanted to do. Yeah, even here too, but down here, wait a second. Yeah, 10, 100, 10, negative, positive, negative, negative, a squared, negative squared 4. What that would reduce to, negative 1, omega squared, okay, 4. 4, well, it's going to be a positive plus 4 omega squared. All the rest of this. And then now we can multiply this in to all of this. Oh, that's gone. Yeah, we'll get rid of that too. So what, 4e negative 3 times 100, and 1, 2, that'd be 0.4. 0.4. Yeah. Oh, right, wait, what am I doing? No, I can't do this. I have to do it in polar coordinates. What am I talking about? Absolutely losing my mind here. What am I talking about? I need to do it in polar coordinates. Multiply. Wait, wouldn't I? Or can I do this? In order to do this multiplication, would I not have to do it in polar coordinates? Oh man, I was doing a bunch of arithmetic. Wait, right? Yeah. Wait, whoa. Is it absolutely always necessary when doing multiplication to have to use the polar coordinates? Is it always necessary to use polar coordinates when multiplying or dividing phasor equations, phasor complex equation, for equations for AC circuit analysis. Alright, no, it's not mathematically necessary to use polar coordinates, but it's highly recommended to avoid tedious algebra. You can perform these calculations in rectangular form, but the process is much slower and more prone to errors. complex conjugate of the denominator to eliminate the j term from the bottom. This takes several steps. Polar form multiplication, multiplying the magnitudes and add the angles. It is much simpler. I get it. Okay, but I mean, I've already went this far with this method, so let's try to continue, I guess. Alright. So, my phone's gonna die. Shit, I erased stuff. That's okay. What it was 100, that's gone, yeah. 100 plus 1 4 omega squared multiplied by j omega 0. Oh yeah, 4e to the negative 3. So 0, 0, 4. 1, 2, 3. Yeah, there's 4 milliamps. Oh yeah, okay, that makes sense. I don't know. Alright. Right. I don't know, I must be missing something. I don't think so. I don't think this was right. Right, maybe I'm just forgetting that I still have the denominator. Okay. Cubed. Wait, so imagine that was 1, negative 3, negative 2, 0.016 omega. Shit. Oh, we already put that. Okay, there it is. There it is. Alright, divided by, right, so 100 plus well, that's gone. Yeah, is that gonna be a plus, minus? It would be negative j squared omega squared and 4. It'll be the same term. J squared would be negative 1, so that would be positive, so 100 plus, oh, that's gone, 4 omega squared. Wait, what? This would all just cancel. What am I talking about, right? That would all just cancel. I'm tripping. 10 plus, it was always there. Is that my fault? How did that, wait. What am I talking about? That would just cancel. Alright, so why would would be negative though? And then that would, oh, this 1's here. Wait, the 1's here. That's where it came from, this. Where did J come from? Oh, those are still there. Shit, I'm losing it. I'm losing it. Oh shit. Let's start recording. Oh fuck. Alright, well I'll start it now. It looks intense. Well, I mean, it's really not. I just I got lost in the sauce, you know what I mean? I started second guessing. But yeah, and I totally forgot to introduce this 1 and carry the 1 along here. Such a stupid thing, you know, stupid mistake. Yeah, but we're adding the 1. Stupid. Right, so this 1, now we're divided by, right? And that's where it comes from, right here, that term. Okay, that's where the J, that's where the imaginary number comes from. We carried that. Okay. And we did that, we distributed all that, and we came to this point, and so we have, okay, our equation is just doesn't, shit. This does not seem right. And it's not even that. It's still over 1 plus 150. It's like this. So I mean, we could flip it. What does that do for us? That is a, yeah, that would last. That wouldn't last. That would be gone. Be a -1. Wait, no, it's omega. What am I talking about? That's literally what we're trying to solve for. Shit. Shit, guys. Fuck. Fuck, I lost it. I lost the sauce. I lost the sauce. Wait, let's run it. Wait. Hold on, let's run it from the beginning. I'm not liking the way it's going. Alright. $10 ohms, 150 ohms. Okay, for millifarad, we hit that. VG, positive, minus. Alright, I not, or I out, whatever. Whatever you want to call it. I'm gonna call it I naught, okay? That's what I'm gonna call it. I like that. I naught. Alright, with everything labeled, we have our parameters. Alright, so let's go ahead and solve for find the frequency in hertz. Okay, we can do that. We can solve for omega, but like, what the shit? That just seemed like I took it too far. Like, I don't know. It just did not seem correct. So let's go ahead and try to do it again. I would assume to do this by an assumption, you know. I guess I'm not entirely sure, but like, that's what I'm trying to figure out. But, you know, to find the total impedance of the circuit, to find the total impedance, and then just divide VG by that. You know, that's like Ohm's law. We're working with, that's the thing though, am I not converting to the phasor? No, the polar coordinates. It's not necessary. It's not absolutely necessary, but it does simplify it. Alright, fuck. Okay. But we're not even doing that yet. This is all just simple addition. Reciprocal. The other thing we can do is simplify that. Let's just start there. Okay, let's just start with alright, this. So 4 millifarads, J omega C. Okay. ZC equals 1 divided by J omega 4 millifarads. Right, ZC equals. Okay. Well, and then we put it into phasor form. Omega. Well, if this is it, it'd just be it'd be the square, it'd just be omega for, wait. Right. Negative 90 degrees. If we're looking at it from what perspective? It doesn't matter, it's just ZC. Yeah, then it's negative 90 degrees. Yeah, for the capacitor. Because I believe that's accurate. Okay, so ZL equals J omega 2. What's it? Just J omega 2. Oh. Equals omega 2 angle positive 90 degrees. Okay, that's the impedance for the inductor. And then for the resistor, it's just its resistance. Okay, it's just 10 ohms. Alright, as we have labeled here. So we'll draw a ground too. Let's not make that mistake. That's our ground. Okay, ZC, ZL. Still, what's the purpose of this now? Because we have addition, so these we just need that. So it'd be right, 1 omega J omega C plus 1 divided by 10 plus 2. Oh, omega 2J. Or J omega 2. I mean, this takes us back to where we were earlier, right? 1 divided by 1 over J omega C. See, now I'm on the roll. Now I'm in the flow. Okay, now I understand what's going on. Alright, so let's solve this problem and call it good. What time is it to do it now? No, my stream cut out. Are we back? Are we back? The stream cut out. No. Oh, that's such bull. No, we're still cutting bitrate. Our bitrate's still dropping. No. What? No. Alright, I think we're back now. Unbelievable. Ladies and gentlemen, unbelievable. Would you get that? Okay. That's where it would come in handy. Alright, I'll just do it now. Well, shit. What? I'm just not seeing a solution in my head. It still all kind of results in the same thing. What am I missing? What am I missing? I'm just trying to solve for omega, for the angular velocity. We know, and then, well, I'm really trying to solve for the frequency, but we know that omega equals 2 pi f, right? So, that would not, and there, Any offers of opinions? Like, where do we take this? I mean, seriously, I don't want to chat in AI. I really don't want to. But I suppose I could. Shit, alright. Or we just think real hard, sit here forever, think about it. I mean, we could just, okay, I guess let's just try. I guess let's just buff it out. So what happens if I multiply this? Okay, so 10 j omega 2, so j omega 10c plus negative 1 omega squared 2c divided by 10 plus j omega 2. Okay. Omega squared, omega, we got a c, that would leave a j and so that would leave a real and a, okay, so like, look at this, so what do we pull out again? Omega 2c leaves negative omega c plus j 5c, no, j5. Wait, that want to be a c there, we pulled the c out. Omega plus j5. See, what the fuck? That doesn't even lead me anywhere. That leads me nowhere. All I'm gonna do is get rid of what? And then it's gonna be squared. Like, what does that do for me? And I forgot the plus 1 again. Plus 1. C plus 1. Because there's a 1 here. Why we do that? Do that. I mean, alright, well, let's just bust it out. I just think, man, I think I'm gonna do a bunch of work and it's gonna lead nowhere. But I guess let's just bust it out then. But yeah, what? Negative omega plus J5. Negative omega plus J5. Wait, what am I making this harder than it is? Am I missing something? Yeah, but I want to solve for omega, but... Wait a second. What is the question? The frequency of the sinusoidal voltage source in the circuit N is adjusted until the current I naught is in phase with Vg. So what does that mean? I naught in phase with Vg. That would mean I naught in phase with Vg. Oh, oops. Yeah, no, maybe there's no reason to do that. I've seen a method before that multiplies by the conjugate, so like, I don't know, I assume that was typical. That's what you had to do, but perhaps not. That can't. That's probably not right. Let me see. See and then consider that. And it's not the total though. It's not the total. But this is the. Well, that wouldn't make sense either. Let's go back to here. Right, that wouldn't make sense. Not the right, but that's the thing. Not the whole thing. Only the imaginary part of the impedance. What am I missing? Shit, dude. I really gotta look it up. That's crazy. No, I don't want to. I don't want to. I don't want to. I can figure it out until they're in phase. Why is that so? What? What am I missing? Right, what equals 0, so the real part is only active part. And what they'd be, I think I considered that. When that equals 0. What about... Oh, you can't see that. Here, I'll do down here. Whatever. Maybe something like this. I don't know. Let's try to take this route. Let's see. Yeah, that's the thing though. So I don't want to do that, but we could do that. So something like that. I don't know. We'll see where it takes us. That's just wrong. Dude, do I have to like use partial fraction decomposition? Like, what's going on here? This is ridiculous. Oh. Oh, how exhausting. Shit. Shit. Alright, fine. Fine, 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 fine. Let's read something. Alright, compare and parallel. Just those two. For a complex fraction. Wait, so let's oh no, these problems get really big, right? I mean, I wouldn't say so. I would say not really. I'm just like, I don't think I really am. I don't think I have the right method. I don't think I know it. So let's apply this. All right, let's apply this. Can we see that? Yeah. Okay. I don't know. Let's abide by this. So I am adding these to be purely real. SAD. Okay. Alright, well, let's start over and apply this. Start over and apply this. Okay. Okay. So this capacitor in parallel with this series connection here, a 10 ohm resistor and a 2 Henry inductor, in parallel with 10 plus this complex equation, J omega L, which is 2. Well, we just have C there, so let's write out. ZP, right? This is what he can, yep, this is what it was considered, right? Right. ZP equals parallel P and ZP, parallel series RL branch, capacitor branch is in parallel with series RL branch. Yeah, we don't take into account this resistor though, huh? Interesting, I guess, you know, supposedly in my opinion, I happen to find that very interesting. So, okay. Well, we can also say negative. So we'll put negative, well, yeah, no, that'd be ideal. Negative J, no, wouldn't it? Shit, I don't know, maybe not. Right, that seems to be the faster route. That works too. But I didn't have that memorized. I only know this by typical analysis. I wanted to add it this way, but it comes very extraneous. Maybe if I did make it negative J divided by omega 4e negative 3. Yeah, well that's it. So that to the negative 1 plus 10 plus J omega 2 negative 1 all to the negative 1 equals. And then what? That needs to equal 0. Well, that needs to equal 0. Interesting. Right, and that's why we do that, correct? Is that the goal? don't know. I can just use this, I guess. Alright, we just have to remember that. Ah, shit, to derive it. Oh, I could derive it right now. I could show you how it's derived. I'm just... Why is this equation so difficult? You know, this is how it's derived. Because they are... Well, okay, let's define ZRL. Okay, ZC is literally just the capacitor and impedance. ZRL equals 10 ohm plus j omega 2. Right, so that's ZRL, and then ZC, and then ZP equals 1 over ZC plus 1 over ZRL. Right, because they're in parallel, right? So that would be ZRL plus ZC, ZRL, -1 equals ZC, ZRL. Right, so that's, that's that law. Sure, it makes sense. But man, when I'm trying to do that shit with the actual equations that I have, why is it? It's not that difficult. Am I tripping? Maybe it's not that difficult. Perhaps I'm going, cuckoo for Cocoa Puffs. Maybe I'm losing it. All right. Well, I think this is still gonna be a bit of a mess. So. Shit. Let's calculate the denominator first. I don't want to calculate that yet. J omega 2. Let's put this into a single equation. So 1 plus j omega 40 plus -1 omega squared 8 all divided by j omega 4 mil. 2 times 4, that's mil also, yeah. 40, that's the 10. Yeah, but that's still mil. Yeah. I think that's it. want track, but like, wait a second. Let me just completely drop the imaginary number. That's what's going on here. Huh. Oh, can't see it. My bad. My bad. My bad. My bad. The fuck, chat? Okay. Yeah, we just divide the whole thing by 2 omega. Can you guys see that? I'm about to conclude. Hopefully this is correct. That can't be right. Oh, shit. That is right. Okay. Alright, so square root of 800, I guess just divided by 8, we can just do that, 10. So equals 10 radians. And we were looking for frequency. That's why I initially said I was wrong, because I forgot the one little step of omega equals 2 pi f. Alright, and then so 10 equals 2 pi f. F equals 10 divided by 2 pi equals divided by 2 pi 10 divided by 2 pi. You gotta use parentheses. 1.59 hertz. All right, and that's our frequency. Okay. Cool. We did it. We done did it. Fucking A, bud. Holy shit, the problem was giving me problems. I mean, I don't know. I didn't know this one, or like this rule right here, considering you have an equation like this. I didn't really know that rule. I mean, I should, right? I definitely should, but maybe now I know. Maybe now I remember. Oh man, I need some water. What time is it? Oh, so much time has passed. Already? Why? Why doth thy time runneth so freely, far from outside our grasp? We can never get it back, so we live the days as if it's our last. Shit, I'm spitting there. I'm a poet. I'm like Dante Alighieri. If I said that correctly, I don't know. I could have butchered it. I'm not really sure. I'm not Italian, okay? American. America. Fuck, yeah. What was the last question? Find the steady state expression for Ig at the frequency found in A if Vg equals tan cosine omega t. So now we're going to consider that Vg equals tan cosine omega t, tan cosine omega t. Okay, right. And then we want, again, we want this, I out, using the frequency that we found, the omega that we found. Right. So okay. And now we need to find the current. So this would be where, okay, now I can actually solve for the total impedance. Can I not? Alright, so 150 plus okay, duh. That took me forever to write. So we have already solved for that one, have we not? I mean, this is pretty much it, right? I think this was it. And that should be good. Then we can use that. And then we have this term. Alright, I think we should be able to do that and apply that, but I need to get my calculator and I'll be right back. Alright, now I'm just going to plug the values into these equations right here. Where? Right here? Well, we have that one, so I guess we can write it out a little further. Yeah, we're just gonna have to convert those into polar coordinates. Yeah, that's the total, so that's z total. Because we need to find the magnitude of I out. Yeah. So, well, that's just, omega is 10, right? Omega equals 10. Yeah, that's right. Rad per seconds is our unit. So 1 minus 100, 800 milli, which would be 0.2. Wait, so 10 plus 20. 1 minus 100, 800 milli. 1 minus is 200 milli. $200 mil, not. Yes, okay, like that. 150 plus. So we convert these into phasor form. That look like square root of 10 squared plus 20 squared is 22.36 phase inverse tangent function of 20 divided by 10. 63.4 degrees divided by square root of 0.2 squared plus 0.4 squared. 447 milli angle inverse tangent of 400 divided by 200. 63.43. Really? Same exact angle, huh? 20 to 10, 400 to 200. Yeah, it's a half. So I guess so. They're both positive. Yeah, that was a subtraction, but that got us there. Shit, I guess it makes sense. So divided by would leave us with an angle of 0. So 10 divided by 0.2, 50, plus 20 divided by 0.4, 50. Wait a second, no. 22.36 divided by 4.447. Oh, still that. 50.02 angle 0 degrees. Because doing a division would be a subtraction of the numerator angle and subtract the denominator angle, right? So 150 plus. So that's real. Oh, wait a second. That's crazy. Z total. Well, this 150, that's angle 0. But if we wanted to add them, we'd want to. So it'd just be the real. So it'd just be 50 cosine. Yeah, cosine 0, so it'd just be 50. there's no phase angle, so it's just 50 plus 150 equals 200. Okay. Well, yeah, and then we have cosine omega t. That's no angle. This is no angle. So it'd be VG equals, or I mean, I out equals VG divided by Z total equals 10 divided by 200 cosine omega t. No phase change equals 50 cosine omega t milliamps. I out. Oh. We know omega. It's 10. My bad. Shit. I can't forget stuff like that. Are you kidding me? Fuck. But that's it. There you go, ladies and gentlemen. I out equals 50 cosine 10t milliamps. Okay, that's your unit. Milliamps, that's a unit of current. Milli. Okay, on to the next. What a bunch of nerds. What an absolute bunch of nerds. I need to charge my phone. Oh shit, yeah, I really need to get on it. Alright, yeah, I'm gonna call it. I got stuff I gotta do, so thank you all for being here. We always have such a wonderful time, don't we? It was very good. We did complete the circuit, the circuits, right, there are multiple